The fun part of the project is seeing all the new stuff that we're going to be putting on. So here we have the IMS Solution in the box. Let's see what's in it.
Hit that subscribe button and turn on notifications by clicking on the bell icon and never miss a video. We've got lots of Porsche content coming your way.
And I'm going to start, well, we've got some hardware here. Well, you can probably talk about that later. Probably the biggest thing is I know there's several components in the original bearing. I think, what, 19 parts or something like that?
Yeah, so when we start talking about this, you know, we got the dual row and the single row. We talked about the dual row having twice as many wear components. It virtually does. There's 19 wear components inside this unit that we are eliminating
with this.
With that. And in the single row, which is half of this, the way that it all adds up, there's 11 because we got races, inner and outer. We have bearing cages, we have bearing balls, and all that. So basically, we are taking all of these wear parts out of the equation. The ball bearing is out of the equation. We're taking all these moving parts, and we are replacing it with this one bushing, okay? And then the IMS Solution flange, okay? And take the nut off of that center stud.
Okay.
It goes like this, and then like this. So basically, we are going to be able to support the radial loads, which is what I'm doing right here by turning it radially with oil now, because we're going to feed oil into here. And then we're going to take the longitudinal loads, which I'm doing here, the thrust loads, and we're going to support that with oil. And the way we do that is oil comes into this small port here, and we're going to talk about where we get the oil from and why we get it from there, and why I did things when I invented this during development to prove that was the place to get the oil from. So we're going to radially support it with oil coming through this feed hole here, okay? And then longitudinally, again, this is longitudinally, thrust-wise, we're going to support that with this feed of oil here, you see. So basically, the center stud retains all of this, and it has this nut that holds it on. So we are taking both the thrust loads from both directions, radially and longitudinally, and we are going to use a film of pressurized oil to support that. We're not going to use all these other mechanical pieces that are inside these original bearings. We're going to take those, and they're omitted from the equation.
Now, this design has come up before in history. This is not completely new and novel.
No, well, in the case of the M96, M97 engine, this is extremely novel, so novel that we were granted 3 patents for this. But in the case of the Porsche engine, the concept of using oil to support the loads of the intermediate shaft is one of the oldest things, because it goes back to the 4-cam Carrera engine, 1953, right? It goes all the way back to then. First time we really saw a lay shaft in an engine. That was the old name of an intermediate shaft. And then all the way through all the 911 series, air-cooled through the 993, they used the same style of arrangement. We were using oil. It was delivered via pressure inside the engine, internally routed through a pretty sophisticated manner of getting the oil through the crankcase up to supporting that lay shaft. And I've got pictures that we can share with you guys so people can kind of illustrate that. But we're taking externally delivered oil. You'll see how we're doing that. And the external delivery of oil is going to come into this flange. We have internal passages inside the flange, which is a pretty sophisticated part to machine. It is made in the USA at Allen Engineering. And we support those loads. So yeah, the first time this was seen was back in the 4-cam days.
Now, the tolerances, which is, I was curious, because I've never played with these parts before, is when it sits on here, I mean, there's no movement, but there's enough movement for oil.
There's enough movement for oil, and there's also movement for expansion and contraction and things like that. This material is very stable and through temperature changes, and this is also a material that is used to carry a lot of load. So this material is very close to the material you'd make a cylinder from, because of its characteristics. It's made to carry a load. It's an expensive material. That's why for aluminum, feel how heavy this is. You know, if that was a piece of 6061 regular old generic aluminum, it would be about half that weight. This has got a lot of other things in the alloy composition. And in the beginning, we only made these for single rows. And you see, that's another thing, another reason why you weren't able to do it back when you did it, is because in the original days, the demand for a dual row was a lot less. The cars weren't worth as much. People didn't really want to do it. They thought the dual row bearing lasted longer. And then now, the dual row, we actually sell more of those than the single.
You talked about getting proper oil to feed into those channels, and I believe this is where we get the oil from. So this is, now my car already has a spin-on oil filter adapter, but this one is a new one, and it looks like it has a little port there for us to get some oil.
So the significance of the spin-on filter adapter, again, it was one of my original inventions to come up with this because I don't like plastic on engines. I don't like a plastic filter housing. I just don't like it. I don't like the fact that I could hit a piece of road debris, you know, somehow and it bust a filter or bust the filter housing while I'm removing it because it's plastic. Now, this area of the engine is heavily shrouded by all kinds of things around it. So the chances of you hitting something and breaking that filter or hitting something and do something with an oil line here are slim to none. I think in all the years we've had one of these damaged and the guy was a rally driver, right? So at the end of the day, when I came up with this spin-on filter adapter, the original intention of this was to supply just filtered oil, just filtered oil to the IMS Solution. Now, many people out there may have something that is confusingly similar to this, but it doesn't have this oil port.
Right.
It is so confusingly similar that you may think that it's the same piece, and you may think that you could drill a hole in it and just put an oil filter, you know, adapter or something. You can't, okay? Because this one is designed to take the oil that has just been filtered from the center of this area here and feed that out to the IMS Solution.
It's not taking the dirty oil that's in this cavity.
It is taking freshly filtered oil and it's applying that to that critical surface. So we wanted to make sure it was freshly filtered oil. In testing, I did it both ways. I did it with non-filtered and filtered oil. I honestly didn't see a difference either way, but at the end of the day, if you can get filtered oil, that's what you want to do. So the original intention of this was to do exactly what it's doing, but several years before the IMS Solution was ever released, not that we weren't testing it, but before it was released, LN came to market with a standard spin-on filter adapter that does not have this oil port, okay? And that was a result of, hey, we're already making this piece, let's just change the program a little bit and make it where it's not giving an oil outlet, and let's give people the opportunity to put a high flow, a good quality filter that doesn't require that plastic canister. They can put that on their engine. So the two are not the same. They don't even use the same filters. You cannot use the same filter between this version of what we call the SPOFA, which is the spin-on filter adapter. You can't use that with the standard, the Solution one. You can't use it with a standard one.
Yeah.
So one uses basically a 1348, one uses a 1042. They are a different filter. You see here we have a 1215, which is a substitute, an alternate filter for the 1348. Okay, so both of these work well, 1348 and 1215. This is the nitty-gritty of it.
What's this cap for?
This goes inside the intermediate shaft itself. We talked about that.
This is to keep the cavity, seal up the cavity.
Exactly, yes. Okay. So we should have this 90-degree fitting right here, actually. And this 90-degree fitting goes into here. I'll just kind of mock the whole thing up. I was going to quickly do it, but I've got to have this fitting in it to really be able to show you guys. And this fitting helps to make sure the oil line is not put into a odd scenario where it's going to end up getting pinched. We want to make sure that oil line is happy and free to move. So it kind of goes together like this. And then this goes in here. Something kind of like this.
Yep.
So that's pretty much what you're looking at right there. And of course, in the engine, everything's kind of lined up differently, and you got the filter installed and all that. But that's the idea here, is to give people kind of the geography of it, and then to show them how we do it on the car.
Do you mind talking about what looks like to be some sort of compass here and a spacer of sort?
So over the years, we've learned that all these engines have manufacturing deviations. And anybody that's ever done CNC machining understands how hard it is to start and end a thread in a certain location, and the factory had a hard time doing that. So when the factory was doing this, they were just going to thread an oil filter canister into the engine. That oil filter canister was just round. It had no special characteristic. It wasn't feeding oil anywhere. It could start and stop anywhere.
Yeah.
Okay? This, we want to park this fitting in the location that we developed the length of this hose and the routing of it to be best suited.
Makes sense.
So out there, probably 85% of the engines, maybe more, have the thread in the block that you can't change that starts and stops in the same location. For those other 15, 20%, whatever it may be, we have to come up with a little bit of math here and a shim that is made to go on this that will stop it from turning a little bit earlier.
I see.
Because sometimes it will rotate too far and it will not allow the hose to be in a happy spot.
Gotcha.
So this shim, with a little bit of math in the degree wheel here, allows you to figure out what you need to do for your clocking. So it's an easy thing. Most people don't need to deal with that, but it is included in the kit just in case, because you want to make sure that the just in case guys are covered.
And I know those parts are important, but this little piece of paper and sticker, I would say, is just as important.
Yeah, so this is very important from a ownership perspective and maintaining an investment in your vehicle, because especially with an IMS solution, it is permanent. So you want to make sure that you go through the proper registration process. And in that case, we would just say you didn't even pull our old original, our old retrofit bearing out. Let's just say this was your original bearing. It got pulled out. It was happy. It was healthy. You go through this process, and then you fill this out. You put one of these on the vehicle. This card gets sent in. That basically locks your vehicle into a registry where this original bearing went back. Yes, we do know it did not suffer a failure. It goes into the registry. It gets logged. And everybody knows at that point that it's been done.
Perfect.
So, and that's important. It's like a Carfax. This is like a Carfax for your IMS bearing.
Right.
And in the beginning, the first 5,000 or so kits didn't have this. And I wanted to do, like all the ones we installed at Flat 6 Innovations, I had my own serial numbers. And if anybody out there sees any of that, they all say Flat 6 Innovations on them. If you see one that says that and it does not say IMS Solution, that goes back to pre-2010. Because before that, I was not doing any solutions as a retrofit, right?
Right.
So if you see that, it's that bearing is a long time in service. If you see one that says IMS Solution, it is permanent, and since it has a Flat 6 logo on it, we did it in-house at Flat 6 Innovations.
Got it.
So now what we have to do is we need to get that a little cleaner in there, okay? And then we're going to have to take the new flange, and we're going to have to hold it up there and then mark the area that we're going to cut out. Okay, so what we need to do is do this. Take this out first, and let's take a Sharpie and mark either side of where the fitting's going to go. So let's screw the fitting in there. Just screw the fitting in. We want to make sure that we cut enough of it out that you can get a wrench on it later, a socket on it later. And then we'll put the old flange back on again so we can have it in place for all the grinding. See. And then when we get toward the very end of it, you're going to have to pop that off and put some towels inside there, because the flange is going to get in the way when you get way on down, because you have to go a little further than what the flange is, see?
Yeah.
But that's okay. You can remove the vast amount of it the way that it is. It's going to take you a little while to grind that. All right, there you go. Just like that. So, yep, what I would do, so you're going to have to try to get that as straight as you can down this way, and then as straight as you can down this way.
Oh, not a hole, it's a notch.
Yeah, you're just going to do a notch, exactly. You're cutting a U out of that. A little bit of that will come off. Yeah,
this piece.
that thicker piece, yeah. There you go.
baby.
Yeah, I got it.
So basically, what we're doing is this is the plug that I told you about that I've used to block off the inside of the tube so it doesn't become an oil reservoir.
Right.
So we machined this with an installed depth, so when this bottoms out against the housing bore, it has put this at the depth in which we have designed it to go to.
Okay.
So it won't let you go too far because this bottoms out, okay?
got it.
So the main thing you want to do is make sure when this goes in that it starts straight. You can see we've machined a little chamfer on here that helps it to start straight.
Okay.
So you want to make sure you start it straight and then drive it all the way home, and when it's done, it should be setting level and flat and not cockeyed inside there, okay?
Yep.
And we have to make sure then that this has gone down the proper depth. Even though the tool should do it, we're going to have to check it and make sure the solution stud that will be kind of almost inside of this does not contact this,
Okay, got it.
because that would make the stud difficult to work with later.
Okay. Now, do I oil it up to slide it in?
No, just go in with it. Yeah, it's made to crush, so it will crush some.
Keep going?
You keep going until it stops.
Oh, there you go. That's definitely stopped.
Okay, there you go. Now look at it, make sure it looks square inside that housing bore, inside the tube. So need
done with this?
the Loctite. Need to put that Loctite on the Q-tip and then swab it around the perimeter.
On here?
Nope,
or in here?
in the plug. We're putting it on the plug to glue the plug in.
So I'm putting
I
it
didn't
in
I
right
didn't
here?
I didn't like how fast that went in all at one time.
Uh-huh.
Because some of the shafts are a little bit bigger than others. So we're going to put the wicking Loctite. That Loctite is wicking grade. So it will literally penetrate around the perimeter and glue that in. This won't dry until you shut the air off to it. So, okay. So now, go back to the freezer and grab that. I wanted to make sure we did this, but that thing was going to start warming up fast.
Yeah.
Okay, I'm going to get it squared up, and then you can drive it in. I might tap it a little bit, and then you can cheat from there. All right, go. Tap it up and down, left and right. Just keep it going. Keep it happy.
I feel like it's...
Yeah, now you are. Now you are. Hear it hit home?
Yeah.
Okay, you're home. You're home. Give it a couple more hits. Okay, that's it. Yeah.
It's supposed to be loose like this?
Yep, that's perfect. That tells us that you got that plug in deep enough. That little piece of material, it shaved that off of the outside of the IMS bushing. Okay, that's fine. Now what you have in here, this is a shim that sets our endplay. So this goes against the bushing,
Okay.
and then this goes against the shim. And you roll this in. You pull it out like this. You start the corner, and then you just push it a little around all the way. And it will wind itself into position, and it'll click.
Like this?
Yep, start that corner and just push it all the way around. Oh, you're getting there. So just wind it in with this, because that glove's gonna you're gonna get a piece of that glove pinched between that clip, and then you gotta pull it back out to get the piece of the glove out. Those gloves can be a detriment. So now we've got to put the bearing flange on. So you want to put some of that on the center stud and take your finger, your pinky, and this is a time where you want to change your glove actually, because you don't want any contamination in there at all. Yeah, now go on the inside of that bushing as well, like on the, look, there you go, all of that. Now we want to clean the flange. There you go. And then you're going to put a little bit of that, just a thin film on the leading edge of this seal. That's going to help that seal go in and stay happy. You'll have to jiggle it just a little bit as it goes in. Yep, that's a good one. Look, here, I'll get a picture of that. See, that's a good, that's the money shot right there, man. That's Voo with a money shot. Yep. Wobble it around a little bit.
There's an O-ring inside the flange you can't see. That's
There you go. There you go. Now you see why we had to make sure that shaft was centered, right? Otherwise, that would have never gone in. Okay, so what I do here is go ahead and put your bolts in. And the reason you want to put the bolts in is so you don't want to drag it in with the bolts, you want to tap it in. But you want the bolts to guide it where it needs to go. So now, go ahead and tap this in. Now the next thing we need to do is have a pair of needle nose so we can grab that center stud and pull it out so we can get a thread caught.
Okay.
But this still has to go in over 1/4 inch, see? Okay, now we just, well, actually we just got to barely grab that until, and we actually might be able to catch a thread now. Grab that nut. See if you can very easily catch a thread. Now go ahead and torque these up. They're 10 Newton meters. And we'll put that at 22 Newton meters.
It's spinning.
Okay. Let me try something real quick.
Speed is your friend, huh?
It's not doing it. Yeah, it's got too much lube on it. So what I've done before is this. So we can try to hold this and do this, okay? Like that. So you have to wind this backward to get it to, yeah, but this screwdriver is too small.
All right, so if you can't tell, we are wearing different clothes. It's a new day. Last night, we worked on wrapping up the installation of the IMS Solution, and I will say it was probably the most nerve-wracking part of it because it was quite invasive out of all the things that we're going to do with this project. Now, I will say that these tools, which were very inexpensive, these were just a rotary wrap set from Harbor Freight.
Made for wood, by
Made
the way.
for wood, but yet we applied it and used it to cut a notch out for the oil feed line that goes into the new flange. And I took my time. It was probably tough for you to watch me do this over and over because we marked it. I started, routering it out, so to speak. Put the new one in, measured it. Wasn't quite right. I think I did it 4 times. And as I was doing all of this, I wanted to make sure that my surface area was clean. I wasn't introducing or shooting any of the shards of this.
Taped all that off.
Taped all of that off, and just methodically did. I wasn't in a rush to do it. And thank goodness, again, I'll say this 100 times before we put the motor back in, but I'm so happy that the motor was out because I had the right leverage. I was comfortable. I could guide the drill in exactly and see everything. I can't imagine how I know there's people out there that can do it in the car, and kudos to them, but I really appreciated the motor being out.
Well, and I would say 90% of the IMS Solution and retrofit installations have been done with the engine in the car.
Yeah.
And when I developed the process, that was the idea. Just you don't need to go any more invasive than dropping the gearbox, pulling the flywheel off, and getting access to the intermediate shaft area. So doing this is not something that happens a lot, but it probably should happen more with the engine being removed, especially on these 5-chain cars that almost all of them are going to have these high cam deviations and be out of range like yours was. And I have to say, a lot of this has been hard for me to watch. And it's because I'm so far removed from my environment with my tools and my stuff set up.
Your pro stuff versus
Exactly.
my amateur stuff.
Well,
Yeah.
that, and it's just, it's hard to do things when you're away from your environment, especially for me, because my environment is so strict in a certain way.
Right.
But I think there's a lot of value to everybody at home to see that you are improvising, adapting, overcoming things. You're using things that are made for wood to do this. You're going to Harbor Freight. You're grabbing stuff from neighbors, whatever. That's what everybody's going to be doing. That's why I really agree to do this is because so many people are doing this at home now. They need to see that you can do this. It's not so long ago that the information isn't out there. A lot of people have lifts at home now, and they can do it. The main problem people have is they don't pay enough attention when they're taking things apart. They don't create their own resource material. They ask the wrong people questions and get bad advice.
Right.
And they ask too many people questions. You know, you ask 4 people, I say all the time, ask 4 people the same question about this and you're going to get 5 answers, right? So being able to pay attention and just be methodical and not introduce debris, those are the things that make you able to do anything.
Yeah, and don't force anything.
That's right.
Like I find myself nowadays, not only with this project, but any project, is if it's something is binding, something doesn't screw in correctly, just take a breath. You walk away if you have to.
Absolutely.
Have a beer if you have to.
Yeah.
Like just take your time. And I like to clean, you know, this is not clean for you, but for being here at PCA with all the tools and not have my toolbox, I reset. If you notice,
Yeah.
I reset after every procedure.
You have to.
I put all my sockets back because the next project, I don't want to have to be looking around the floor or wherever I was using it.
Well, what I tell people in my classes, and even I told you this, is, you know, when you're doing something that is a lot of work like this and a lot of steps, you don't think about any step other than the one you're doing right now. If I'm wiring a car and it has 200 terminal connections I've got to make, I don't care about 199 of them. I care about the one that I'm getting ready to connect. I connect that wire and then I go to the next one. Same thing with this. You know, it's one step at a time. We have to put that plug in the shaft first. We don't worry about all the rest of it. We put the plug in the shaft, we get the confidence we did that, then we're like, what's the next step? We focus in on that step, we get that step done to the best of our ability, and we go to the next one. What really causes a lot of do-it-yourselfers problems is they will pre-watch videos on YouTube, and they see the entire spectrum of everything. And that spectrum gets in their mind, and they're like, this is a lot of stuff to do. Overwhelming.
Yeah.
You can't do that. You're going to be your own worst enemy if you worry about things before you need to worry about them. I just did this with the 7th graders in the life skills class where we used my technical learning stations, and I taught them to do that. The first day was a nightmare with them because they tried to go in the workbooks and go ahead. But they walked into the class the next day and there was no workbooks, and we didn't use a book anymore.
Oh.
So everything was smooth. But I have to think that no matter what somebody's doing at home, it's a challenge to keep their mind focused on that next task and only that task.
Absolutely. Well, let's continue.
Let's get it done. So now at this point, we need to march on with all the work being done in the bell housing area. So the next thing on the list is removal of the rear main seal, or you may know it as the RMS. So at some point, this one has been changed. It's not an original one. When we get it out, we'll kind of be able to tell a little bit more about which generation it might be. And if it's just regular old black rubber, silicone, or it does not look to be, but it could be an early version of the PTFE seal. So there's no special tool for doing this. So Vu is just going to use a small 1/8 inch or so drill bit. He's going to find one of the perforations in the seal. He's going to drill through that, and then he's going to use this special drywall screw, and he's going to thread that in, and then we're going to use a pair of pliers to lever that out. There you go. That was good.
Here we go.
All right, now lever the other one and it should come right out. There you go. Boom. And it was a PTFE seal, so you don't want to get any oil or anything on that PTFE surface. Just kind of like that, like hold it up squarely. And this is almost acting like a seal compressor at this point. See what I'm saying?
Okay.
Yep, and then it'll just deliver it right over that lip. And then you're just going to tighten it till it bottoms out, and then you're done.
Just do,
creep it from side to side.
Side to side.
Okay, that's it.
Yeah.
Right back up. Zip you up.
So I'd probably say over.
Ta-da!
Yeah. It definitely isn't deeper than the last one.
Yeah. And that's okay?
Yeah.
They want it that way because the old one makes a little groove on the crankshaft, and if you put the new seal right back where the other one was, it'll hit that groove and the seal up. Okay, so now while we're here, we may as well put the flywheel back on. Yep, you're going to put 12 o'clock on every bolt.
Okay.
Yep, and then we're going to make that 12 o'clock,
To 3
tighten it to 3 o'clock.
Huh.
Because it's a right angle, so you can do that. I'm going to get up here, I'm pulling this pin out
Yeah.
because the pin locks the crank.
Yeah.
But that lock is not meant to hold anything.
Okay.
So if we left this in
Okay.
and you torqued it,
You
you
could-
could break the block.
Right.
See what I'm saying?
Right.
So I need that 24 wherever it went.
The,
All right, I'll counter hold this.
Okay, everything's at 3 o'clock.
Okay. Look at the disc and see which side said gearbox. I think it was the nipple side.
Right. Yep.
So gearbox is this way, so that means
So
the disc
gearbox
goes like that.
side,
The disc goes like that.
box side. So this goes like this.
Mm-hmm.
Well, I need my tool.
What I do is I go ahead and take this and stick it up there and put the tool through it,
Okay.
and then the tool will go through the pressure plate. Yep, look at that.
Okay.
And then put that over it. Now it has balance marks, so you got a balance mark right here, and
Left and right.
no, right there.
Okay.
So those V's line up with those O's.
Wow.
If you had all stock, you wouldn't have any of that. But that was the way it was on my balancer.
Okay. So the IMS solution is in, and now we're starting to put things back together. What we did first, before we threw on the flywheel, was we wanted to make sure we replaced the RMS seal, which is this piece here. What was in the car, I'm not exactly sure if it was a original piece or not, but we wanted to make sure that we put a genuine RMS seal back into the car. The procedure was quite interesting. It was nerve-wracking for me because I had to put a drill into the recesses of the seal and then use these super high-performance wood screws,
Special tools.
drywall screws, and just go in enough to create leverage and be able to pull the seal out gently and not mess up any of the environment in which it came out of. Now, putting it in, now there's a couple of ways, and the new seal came with this plastic piece in the center where you could line it up and then sort of slide it over and get it started. And there's two tools that are available. What's this one?
Okay, so this is the genuine Porsche factory tool designed for this job. And these tools have different adapters that you can use for different engines. So there's a Cayenne insert, there's different inserts for different engines where the body is the same, and then the seals are all kind of the same, but they're different diameters for the crankshafts.
Yep.
So this tool is expensive, it's very easy to use, and with it, you actually leave that sleeve inside,
Okay.
and then it delivers the...
Oh, so this
it
lines
delivers
everything
it.
all in
Yes.
one.
So
Okay.
it does three things. It sets the ID and OD of the seal where it needs to go, and then it also delivers it to the proper depth. So the depths have changed over time because as the engine runs and gets miles on it, the seal will actually dig a little groove in the crankshaft. So it's important that every time you put a new seal in, that it doesn't go back where the old one was, otherwise it will start to leak over time. So they changed the installed depth of this seal several times from the time the cars were new. They also changed the seal material. The original ones were just a regular old black rubber. Then there were some silicone ones for a while, and then they went to this PTFE, which has solved basically all the rear main seal problems. So this tool is heavy duty. It's also expensive. So this tool here is the rental tool that LN Engineering gives
Offers,
out,
yeah.
that you can rent from LN if you buy your products from LN directly, meaning your solution kit.
Okay.
So this one, it does the job, but you do not use the sleeve inside of here.
Yeah,
You'll
I
actually
just
use that just to hold it up
Hold it
there.
up and guide it and slide it
Yeah.
on. Okay.
And then you pull the sleeve away, and then you just tighten these two bolts up, and then it puts it to the same depth this does. So that's critical. When this tool was made, it was set up so it had the same installed depth from the back of the flywheel to where the seal needed to sit inside the crankcase housing bore.
Any recommendations or warnings about getting things on the surface of the
Yes. So there's actually been whole technical articles driven toward this. And the main thing is you do not lubricate the seal inside or out, and you do not touch the internal portion of it, which is the PTFE, with your fingers or with anything. You don't want oily gloves, nothing on it, okay? That's why it has the sleeve to protect that. So the sleeve's doing two things. It is helping guide the seal onto the back of the crank, and it also is covering that PTFE so it does not see a contamination.
The other thing we did when we drilled out these holes here, of course you're going to have a little bit, there's metal here that came off here, and very little bit of metal inside the lip where this rests. And instead of shooting brake fluid or something to clean it, I actually just put a towel, a clean towel around a screwdriver and just kind of wiped it so it doesn't fall into the engine.
Correct. And then when you drill it, you got to make sure that you don't go too far because there's critical things just on the other side of that. So
Right.
Vu actually put some tape on his drill bit to know he couldn't go further than that. And he was very quick. I mean, you was just through it really quickly. So as you start to see that you're making chips and you're drilling, you know, it's going to go through it fairly quick if you got a good bit at that point.
Yeah.
And then we always just use a drill bit that's a bit smaller than the shank of this drywall screw because you want to make sure it goes in and has enough grip that it will pull the seal out. If you make it almost the same size, it just rips it out. So people look at it like, you know, that's kind of a hokey way to do that, but at the end of the day,
It works.
there's no special tool for this seal to remove it. And I've actually seen people damage crankshafts trying to use a typical, like the hook style seal puller
okay.
because this is so thin, they go in and grab it and it makes a nasty groove in the crank.
Oh, yeah.
So, you know, improvise, adapt, and overcome.
Yeah. The other thing is make sure you have a sharp drill bit because you want the speed and the rotation and the sharpness of the bit to cut through as opposed to putting too much
Yes.
pressure on it.
I told Vu, I said, as you're doing that, let the bit do the work because if you start pushing it hard, as soon as you break through, you're going to go inside and
Right.
you don't want to go there. There's timing chains back there, another guide back there. So,
All right, so we got our new one in, and then it was time to put the flywheel on. That went on fairly smoothly, and then it was time
you just
to
had to align your balance marks.
align the balance marks, exactly. And that's a good point, is the whole assembly, the flywheel, the clutch, pressure plate, I had, or Charles, deliver these to you so that you could actually balance them before we install them.
Yes, in my dynamic balancer. So the thing is, I didn't really do that from a perspective of they're too far out of balance. I did that to quantify that there was no manufacturing defects that were going to make anything run elliptically.
Yeah.
So we've seen this with all kinds of parts. Doesn't matter if it's aftermarket, factory, racing, whatever. I've seen, since I balance every engine I build, we've seen parts that don't run true. And if it does not run true, you cannot balance it. So the balancing dynamically in my balancer actually allows us to see that there's nothing running elliptically. And if it's a little bit out, we can balance, remove some material and balance it. So you saw how much material we had to remove from the flywheel.
Damon, you can see that mark there where we moved a little bit of material Next, after the flywheel was back on, it was time for the clutch and pressure plate. A tool, interesting enough, I've done clutches before, and in the past, this guide pin was included. But in this setup, it wasn't. Thank you to Mike at TPC Racing. I ran over there, and he let me borrow this tool to line up the clutch and such. And so what we did first was we put this plate on, and you'll need to make sure and read which faces the transmission versus which faces the engine. And
that's the gearbox side.
And it says gearbox on this side. Line that up. Then with the new pressure plate, line that up. And because you balanced the pressure plate and the flywheel together, there was a mark that you made, which we lined up there.
So you could put that together exactly the way I balanced it.
And with regards to the bolts, you also had me make sure that I removed and replaced the bolts in the same location.
Because they were on the flywheel and pressure plate when it was balanced. So, you know, 1/10 of a gram at that kind of a diameter makes a big difference in the overall balance.
All right. And the last piece, which we have right there, Manny, if you can hand that to me. We won't use it just yet, but something we don't want to forget about, this piece here.
Yeah, the release bearing. So a few minutes ago, Vu was like, hey, where's that at? I said, it's still in your gearbox. So we've even seen people over the years, even professional technicians, from time to time will forget to install this. And then it's usually laying in the top of their toolbox, or maybe it did not come in the kit. Or somebody was working at 3 o'clock in the morning type thing. But yeah, you got to make sure that you replace this. This is a point of failure as well. Anytime you do the pressure plate, or to me, anytime you go into a gearbox, I always double check this. Sometimes you can check them, and if they don't feel grainy and they don't have wobble to them, then you can leave them. But these, you know, a lot of plastic inside these, not like the old ones that were just a big ball bearing, and they were really strong. I'll replace these every time I get a chance.
There you go.